Dotted line represents the strict inequality. So that means when we use the dotted lines, the points on the line are not the solution because we doesn't have equality. This line divides the entire coordinate plane into two regions. One is above the line and the other region is below the line. Now see here, if you take this region satisfies only for the line 3x plus 3y, not for the line x plus 2y. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, we'll be studying about the linear inequalities and their graphical representation. So note that the linear inequalities, if we replace it by equality, it always represents a straight line. Since a linear equation is in the form of ax plus b is equal to 0. So unless and until if equality is replaced by these symbols, it is called as inequalities. So to represent these inequality in the graphical representation, we will take equality for a given inequation. Then we will consider a coordinate plane x and y axis here. So we'll draw a line. So let this be a line which represents some equation ax plus b is equal to 0. Now here, so when I say the linear equation is ax plus b is less than 0 or ax plus b greater than 0, so this line acts as a boundary. So this line acts as a boundary. So ax plus b less than 0 means, so it is the region where it contains the solution points, so which is this region. And when I say ax plus b greater than 0, that will be the solution region which contains all solutions points in the entire region. So the entire region above the line will act as a solution region. That means any point on the solution region will act as a solution for the given inequality. So how to find out this solution? So whenever a line is drawn, consider any point from the coordinate plane. For instance, I'll consider 0, 0. Now let me assume an equation 2x plus 3 less than or equal to 0. Now if I take the point 0, 0, which means x is 0, so y is not there, so we'll just take the value of x. So clearly we'll get 0 less than or equal to 0. So here 0 less than 0 is a false statement. If we replace this by equality, then it is a true statement. That means this point lies in the solution region. So this point lies in the solution region means, so the point or the region where the 0, 0 point exists will act as a solution region. If our statement is wrong, consider an equation 3x plus 4y greater than or equal to 12. Now, if I take the same point 0, 0 here, then 3 zeros are 0, 4 zeros are 0 because x is 0, y is 0. We'll get greater than or equal to 12. So here we get 0 greater than or equal to 12. Is it a true statement? 0 greater than 12? No, it's a false statement. That means here I have taken a point 0, 0 and I have verified the inequation. So here getting the statement as false. So therefore I should shade the region here which does not contain 0. So which is the region which does not contain 0? If I take this as a boundary, this is the region. So I need to shade this region. So this is how we will recognize the solution region in a graphical representation for a given linear inequality. So the next thing is, if the equation is having these two inequalities, these are called as strict inequality, then the line is used or drawn using a dotted lines. Again, when we draw a line in the coordinate plane, it divides the coordinate plane into two regions. So based on the condition, we'll find the solution region. Now, if the equation is given with these two inequalities, so these are called as slack inequalities, then we will use a dark line as a boundary. So dotted line represents the strict inequality. So that means when we use the dotted lines, the points on the line are not the solution because we doesn't have equality. But when we use the dark line, the points on the line also forms the solution for the given inequation. So this is the difference between your slack inequality as well as strict inequality. Now let us take few examples and we will study the solution region for the given inequation. First one is x greater than minus 2. So first let us write the coordinate plane x and y axis. So let us consider this x dash, two perpendicular lines, y dash, and this is the origin. So this is x is equal to 1, 2, 3, minus 1, minus 2, minus 3, y is equal to 1, y is equal to 2, y is equal to 3, y is equal to minus 1, minus 2, minus 3. Now my question is here, x greater than minus 2. So let us take this equation as x is equal to minus 2. So where is the point x is equal to minus 2? Here is the point x is equal to minus 2. So at this point, draw a line parallel to y-axis. So this is the equation which represents the line x is equal to minus 2. Observe the inequality here. This inequality is a strict inequality. So instead of dark line, we are supposed to draw a dotted line. So I'll draw dotted line here passing through x is equal to minus 2. Now observe the inequality. It clearly says x is greater than minus 2. So any number greater than minus 2 means it comes after the line. So that is towards the right hand side of the line. So here greater than minus 2 means this region. So we need to shade this region completely. So this forms or acts as a solution region for the given inequation. So now this is the line x is equal to minus 2, and when I say x greater than minus 2, so this region is the solution region. Next we have y less than minus 3. So let us consider the coordinate plane x dash, y dash. So here 1 unit is nothing but 1 centimeter. So we will write the points here. Now, here we need to take the equation in the form of y is equal to minus 3. So, what is the line y is equal to minus 3? So, here it is 0, y is equal to minus 3. This is y is equal to minus 3. So, since it is a strict inequality here, we will draw a dotted lines at y is equal to minus 3. So, this is y is equal to minus 3. Now observe the inequality here. It says less than minus 3. So this line divides the entire coordinate plane into two regions. One is above the line and the other region is below the line. So now here it is strictly less than. When I say less than, obviously the region below the line forms the solution region. So here we need to shade this region which represents the solution region. Next question. We have 3y greater than or equal to minus 6. So first let us simplify this equation. So now we have 3y greater than or equal to minus 6. Let us divide by 3 on both sides. Then we will get y greater than or equal to minus 2. Now let us consider the equation in the form of y is equal to minus 2. So let us draw the coordinate plane. So 1, 2, 3, minus 1, minus 2, minus 3, minus 1, minus 2, 1, 2. So x dash, y dash. Now we need the line y is equal to minus 2. So this is 0, y is equal to minus 1, y is equal to minus 2. Observe the inequality here. This is a slack inequality, which means it also includes the equality. So here we'll use the dark line to draw the line. Now this is the line y is equal to minus 2. So it is dividing the region into two parts. One is the region above the line and the other is the region below the line. Now which is the feasible or the solution region here? So clearly it is greater than minus 2. So when I say greater than minus 2, obviously minus 1, 0, 1, 2, 3, it goes like this. It goes upward. So we need to shade the region above the line here. So therefore, this forms as the solution region. So that means the points on this region, this entire region is the solution region. When I say above, that entire region will form a solution. Also, the points on the line acts as the solutions. Next question we have 3x plus 4y less than or equal to 12. So now here let us consider the equation in the form of 3x plus 4y is equal to 12. So this is the linear inequality in two variables. So we cannot draw without knowing the points. So first let us find the points. For this purpose, I'll find the value of x and y by inspection. Now let me take x as 0. If I take x as 0, then I'll get 4y is equal to 12. So y is equal to 3. So the first point is 0, 3. Next, I'll take y as 0. If I take y as 0, then 3x is 12. So I'll get 6. So second point is 6, 0. So I need to plot the points 0, 3 and 6, 0 on the coordinate plane and draw a line segment joining these 2 points. So now let us consider the coordinate plane. X, x dash, y, y dash. Now here, let's plot the point 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 1, minus 2, minus 3. Let us consider the points here. So that is 0, 3. So 0, 3. So this is the point 0, 3. So write that point 0, 3. Next we have 6, 0. So 6, 0 on the x-axis. Now join these 2 points. So before joining, let us see the inequality. So it is less than or equal to, which means we can draw a dark line. So join these points. Draw a straight line passing through these points. So what is the equation of this line? 3x plus 4y is equal to 12. Now we need to find out the solution region. So when we are finding the solution region, here we can take any point, any convenient point, either on the any side of the 2 planes here. So now this line is dividing the region into 2 planes. So this is the plane 1, which is one region, and this is another plane, which is region 2. So now I can take any points from any region. Now let me take the origin here. So origin is 0, 0. I need to substitute the value of origin here. That means origin value is 0, 0. Let me substitute 3 zeros are 0, 4 zeros are 0, less than or equal to 12. So we are getting 0 less than or equal to 12. So it's a true statement. That means origin is a point which satisfies the given equation. That means origin lies in the solution region. So which will be my solution region? The region which contains the origin. So therefore I need to shade this region now. So this entire region is the solution region. Now if suppose I get the statement false, I need to find the region which does not contain the origin. That means the region opposite to the region containing origin. So now since my statement is true here, origin is one of the solution for the given inequality, and where does my origin lies? In the region 1. So region 1 will be the solution region. So like this, we'll draw a line considering the inequation in the form of an equation where the straight line, whether it is in the dark line or it is in the dotted lines, that will be the boundary. So that boundary divides the coordinate plane into 2 regions. So looking at the inequality condition, we will find the solution region, whether it lies in the one region or it lies in the other region, depending upon the inequalities. Now, next we will solve the simultaneous linear inequality. That means we will be having here 2 or more linear inequalities. So, we have to find the common region which satisfy all the linear inequality. Let us take an example. So, next is system of linear inequation in 2 variable and their graphical solution. So, the first is x greater than or equal to 3, y greater than or equal to 2. In the same coordinate plane, we'll draw 2 lines and we will find the common solution region. So now let us draw the coordinate plane. Y, y dash, origin, x, x dash. So 1, 2, 3, 4, minus 1, minus 2, minus 1, minus 2, 1, 2, 3. Now here, my first equation is x is equal to 3. So where is the point x is equal to 3? Here is the point. So let us draw this line. So this is the equation, x is equal to 3. Since the inequality contains equality, we are using the dark line here. Next is y greater than or equal to 2. So this is the line, y is equal to 2, passing through 2. So this is y is equal to 2. Now, let us see the conditions here. Here x is greater than 3. So this is 3. When I say greater than 3, the solution region will be this side. Now, y greater than 2. So this is the line y is equal to 2. When I say greater than 2, this is the region where it falls. Now, what is the common region which satisfy both the condition? So here is the region which satisfy both the condition. So therefore, this is the region which is common to both x and y line. Next equation. So we have 2x plus y greater than or equal to 8, x plus y greater than or equal to 10. So here we have two variables in the linear equation. So let us find the coordinates and then draw a line and then we'll find the common region. So now I'll consider this equation. I'll consider it in the form of equality. I'll take it as 8. Now I'll find the points. So x, y. If you put x as 0, it's easy if you take x as 0 and y as 0. We can also take any other points other than 0. But if you take 0 and 0, you will get the points very quickly. So if you take x as 0 here, then we'll get y as 8. So the first point is 0, 8. Next, if I take y as 0, then 2x is equal to 8 implies x is equal to 4. So the first point is 4, 0. Now let us draw this line on the coordinate plane. So I'll consider here. So 0, x, y. So now here I'll take this in the form of 2, 4, 6, 8, 10. Here also I'll take 2, 4, 6, 8, 10. So the first point is 0, 8 and the next point is 4, 0. Now since it is an equality, we can draw a darker line. So 0, 8, 4, 0. So draw a line joining these 2 points, 0, 8 and this is 4, 0. Draw a line passing these points. So the equation is 2x plus y is equal to 8. Next is I have x plus y greater than 10. So let's find the coordinate point. I'll consider it as x plus y is equal to 10. Now here x, y. So x plus y is equal to 10 here. If I take x as 0, y is 10. So the first point is 0, 10. And if I take y as 0, then x is 10. The second point is 10, 0. So let us draw the line here. So this is 0, 10 and this is 10, 0. So join these two lines. So this is the region. So what is this line? X plus y is equal to 10. Now observe both the inequality here. Both are greater than or equal to 8. So my first equation is 2x plus y greater than or equal to 8. So when you are deciding the solution for these type of equation, I told you take any convenient point whichever you want and substitute whether it is a true statement or a false statement. Now here I always prefer the convenient point as origin because it is very easy to simplify. So if I take the origin 0, 0 here and if I substitute here, I'll get 2 zeros are 0 plus y 0 greater than 8. So which means 0 greater than 8. It's a false statement. So that means this is the region. If you observe this line, this is the boundary. So this is the region which contains 0 and this is the region which does not contain 0. Now I have taken a point from this region which is actually giving us the false result. So therefore, for this line, I need to shade the region opposite to the region containing 0. So that means this region, this entire region will fall for the solution. Now let us take x plus y greater than or equal to 10. Now here also if I put 0, 0 here, I will get 0 greater than 10, which is again false. So that means for the given line x plus y is equal to 10, this region contains 0, this region does not contain region. Then region containing 0 gives us the false statement. So I need to shade the region which is above this line. Now when I am talking about the common region, for this line also the region is above the line. For this region also the region is above the line. So what is the common region? Obviously this acts as the region which satisfies both inequality. Now if you take this region, this is true only for the line 2x plus y is equal to 8, not for the line x plus y is equal to 10 because it is less than 10. So to take greater than 10, this is the solution region, and to take greater than 8 also, this is the solution region. So the shaded region in blue will be the common region for both the linear inequalities. Next question, 3x plus 3y less than or equal to 6, x plus 4y less than or equal to 4, x greater than 0, y greater than 0. Here, x greater than 0, y greater than 0 is nothing but your x-axis and y-axis. So, when I say greater than 0, it is above the x-axis. When I say greater than 0 for phi, it is after y-axis. Now, let us solve only for these two equations. So, we have 3x plus 3y is equal to 6. I'll take is equal to for both the condition, and here we have x plus 4y is equal to 4. So let us find the coordinates for both the equations. Take x as 0, 3y is 6, so y is 2. First point is 0, 2. Take y as 0, again x is 2, so the point is 2, 0. So for this equation, the coordinates is 0, 2 and 2, 0. Now let's find for this x and y. Take x as 0, 4y is equal to 4 implies y as 1. So the point is 0, 1. And we have y as 0, then x is 4. So the point is 4, 0. First let us plot this equation and then we'll go with the other equation. Now since x is greater than 0, y is greater than 0, it always indicates the first quadrant. So we will draw a coordinate plane like this, which includes only the first quadrant. Now this is the origin, 1, 2, 3, 4, 5. 1, 2, 3, 4. Now for the first equation, it is 0, 2 and 2, 0. Plot this, 0, 2, 2, 0. So this point is 0, 2 and this point is 2, 0. So draw a line joining these 2 points. What is the equation of this line? 3x plus 3y is equal to 6. For the next equation, the points are 0, 1 and 4, 0. So 0, 1 and 4, 0. So this is the point. So join the line joining these 2 points. So what is the equation of this line? X plus 4y is equal to 4. Observe the inequalities here, both are less than or equal to the given value. Now here, let me take 3x plus 3y less than or equal to 6. Put 0, 0 to verify the solution region. That means whether 0, 0 is one of the solution in the given region or not. So here if we put, we'll get 0 less than or equal to 6. So it's a true statement. So that means for this line, the region containing 0. So this entire region containing 0 will be the solution region. Now let me take one more, that is x plus 4y less than or equal to 4. Again put 0, 0 here also. So we'll get 0 less than 4. Again it's a true statement. So that means for this line also, the region containing 0 will become the solution region. But In the question, they have told you x is greater than 0, y is greater than 0. So I need to find the common region which satisfies both the inequality only in the first quadrant. So which is that common region? So you can see here, this region here in the first quadrant will be the solution region for both the inequalities. Now see here, if you take this region satisfies only for the line 3x plus 3y, not for the line x plus 2y. If you take this region, it satisfies for the second equation, not for the first equation. So this is the common region which satisfy for both the inequalities. So this is the feasible region for the given system of linear inequalities. We'll take one more example. 3x plus 4y greater than or equal to 12. 4x plus y greater than or equal to 8. So 3x plus 4y, we'll consider the equation as is equal to 12. So let's find the coordinate point. If you take 0, y is 3. So the point is 0, 3. And if you take y as 0, the point is 4. So it is 4, 0. Next we'll take 4x plus y greater than or equal to 8 here. So let's find the solution by taking the equality, not the inequality. So x, y, x is 0 if you take, then y is 8. So it is 0, 8. And if you take y as 0, then x is 2. So it is 2, 0. Now let us plot these points inside the graph. Now consider the x and y axis. Since the points are in the positive values, I'll take the first quadrant for convenience. So now 0, I'll take 2, 4, 6, 8, 10. Similarly 2, 4, 6, 8. Now for the first equation, it is 0, 3 and 4, 0. So 0, 3 means in between 4 and 2 we'll get, and 4, 0. So this is the line for 3x plus 4y is equal to 12. Next, 4x plus y is equal to 8 coordinate is 0, 8 and 2, 0. So 0, 8 and 2, 0. So this is the line. So what is this line? 4x plus y is equal to 8. Now let's find the solution region for both the lines. Now here you have greater than or equal to in both the inequation. So let's take 3x plus 4y greater than or equal to 12. So put 0, 0 here. That implies 0, 0 greater than 12. So which is a false statement. That means the region containing 0 is not my solution region. Then for this line, which is the region which I have to shade? So this is the region I have to shade, because this region does not contain 0. Next, let me take the equation 4x plus y greater than or equal to 8. So for this equation also, if you put 0, 0, we get 0 greater than 8. Again, it's a false statement. So that means for this line also, I need to take the region which does not contain 0. So we need to shade the opposite region. So this region falls as the solution region. Now which is the common region? So this cannot be the region, this cannot be the region, this cannot be the region. So here, so the region this will act as the solution region. So not any of the region here. So entirely, so it is in this form and above this. So since both are greater than the real numbers, so this is the common region which satisfies both the inequalities. So thus, in today's session, we have discussed to find the solution of linear inequalities with the graphical method. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.